I hope you're all doing well, staying warm despite the winter storm. I'm sad we can't be together, but I'm going to get through the Module 10 review via video so that you all have a good idea and can start preparing for your test. If you have any questions, just send me a message. Okay, so to get started, the first question asks about acids and bases. So big thing to know here for your test are the differences between acids and bases. This is just memorization type stuff we went over in the notes. So remember acids have a pH below 7. They taste sour. They turn blue litmus red. They conduct electricity in solution. And they donate hydrogen ions. Conversely, bases have a high pH, so greater than 7. They taste bitter. They turn red litmus blue. They're slippery. And they receive hydrogen ions. Remember the acronym BRAD, bases receive, acids donate. Okay, make sure you know those properties of acids and bases. Okay, jumping down to question number 5 from the review relating to the term amphiprotic. And we remember that amphiprotic means a substance can act as an acid or a base. With water being the most common amphiprotic substance. Okay, and then indicators are substances that change color when exposed to acids or base. I'm going to take a picture really quick if I can find my phone, since I didn't take a picture of this before I started. Okay, and then not covered in the book, but important here and will be covered on your test, how to name acids. So I'm going to talk through that again. If you have the notes, cool. If you don't, make sure you get this here. So the way I name an acid is going to depend on if it's a binary acid or a ternary acid. A binary acid being hydrogen, some number of hydrogens, and one other element. And the way I will name a binary acid is hydro, whatever that element is, ic acid. Make sure if it's a binary acid, you use the term hydro before the name of the acid. Alternatively, if I have a ternary acid, meaning I have some number of hydrogens, some other element, some number of oxygens, or you could say this is a hydrogen and a polyatomic. I'm going to name this based on what my polyatomic is. So if my polyatomic ends in 8, my acid will end in ic. If my polyatomic ends in ite, my acid will end in OUS. Okay? Everybody remembers this from the notes. So I'll do a couple practice examples here. In this case, I have a ternary acid. I have hydrogen and a polyatomic. When I look at my polyatomic sheet, this is nitrite. Because it's nitrite, this would be nitrous acid. Again, a ternary acid, I have hydrogen and a polyatomic. When I look at the sheet, this is carbonate. Because it ends in ate, my acid will end in ic. So this is carbonic acid. Notice here that I'm not using the word hydro for ternary acids. Okay. Moving on to C, I have HF. That's binary, hydrogen and one other element. So I will name it hydro, whatever that element is. In this case, fluorine. So fluoric acid. D, can see here that I have more than just hydrogen, another element. So this is ternary, no hydro. ClO2 is chlorite. So this will be chlorous acid. And then lastly, HCl, hydrogen and one other element. So that's binary. We've named this one several times. Hydrochloric acid. Make sure you know how to name these for the test. Okay, I'm going to jump down to questions 8 and 9. 8 is give a balanced chemical equation for reaction between H3PO4 and CSOH. So in class I mentioned the book will go through several different types of acid-base reactions, but what I really wanted you guys to focus on was the neutralization reactions. So remembering that for neutralization, my acid will react with a base, and I think you can't see that. Let me skip this down, to form water and salt every time. Remembering that water, of course, is H2O and a salt is an ionic. This is not legible. An ionic compound. Okay, so balanced chemical equation for the reaction between phosphoric acid and cesium hydroxide. So if it's the reaction between those two, obviously I'm reacting one with the other. What am I forming? Water and a salt. So start with water, and then I have to determine my salt. So remember, my hydrogens here will combine with my hydroxides to form water, and I'll be left with what is there. So I have cesium, not calcium. Cesium is +1. Phosphate is -3. So when I switch those, I'll have CS3PO4, and then I need to balance. Okay, 3 hydrogens need to react with 3 hydroxides to make 3 waters, and then that's balanced. Of course, if you need to take longer to go through that, by all means, do that. Okay, same thing here with number 9. Reaction of HCl, so hydrochloric acid, with beryllium hydroxide. What am I forming? Water and salt, because this is neutralization. And I believe in the test it says write the neutralization reaction between these two, so it's very obvious that that's what we're going for. Okay, in this case, hydrogen combines with hydroxide. I'm left with beryllium and chlorine. Beryllium is +2, chlorine -1, so BeCl2, and then I need to balance. 2 hydrogens react with 2 hydroxides to form 2 waters. Check your beryllium, check your chlorine. Everything's happy. I'm going to stop the video here, and I'll make another one for the next page.